Hello everyone. Today we are going to just take a quick crash course into log functions. I'm not expecting that you have seen these before, um, but hopefully by the end of this couple minute presentation you'll have a quick idea of how they work. So let's look at a quick set of data that I was checking out. Saw this comparison of sizes of different things, varying from a small tiny electron to the sun. Okay, and I have this approximate sizes in meters of, like, say, their diameter or their length. And you can see there's quite a bit of variation here, the electron being much, much smaller than the second largest thing, the atom. If you notice, an atom is actually 100 million times larger than an electron. The virus about 100 times bigger than an atom. Animal cells about 100 times bigger than that. And the human is over 1,000,000 times larger than the cell. So you guys know I like to graph things. So let's see what this looks like on a graph. Well, here's my first graph that I made, and it's not a very satisfying graph. I pretty much can only see two bars, one bar for Earth, one bar for the sun. My picture's covering that up, but everything else just looks flatlined. What's the problem? Well, hopefully you can see the problem is my X or my Y scale. My Y scale starts at 0, which is good, but the next tick up is 100 million. And it turns out nothing's close to 100 million other than the Earth and the Sun, so everything seems to be flatlined. So there is a way that we can fix this problem and compare things that have very different sizes. Okay, to do that we need to use what's called a log function. Right? So what I did, I just used Excel to take the log values of these different sizes, and you can see the electron has a size of 10 to the minus 18 meters, but its log of that is minus 18. Atom is 10 to the minus 10, but the log of that is minus 10, and so on. A blue whale has a size of 25 meters, but its log is 1.4. Let's see where those numbers come from. So here's our basic definition of log. The log of 10 to the x power is x. This is called a base 10 log, and we use base 10 because that's the base that we count in. So let's see if we can do a couple practice problems. Okay. So if I want to find the log of 100, in order to do that I need to convert 100 into some power of 10. 100 is 10 to the second power. Log of 10 to the second power is 2. Okay, let's try one more. Here we've got a number smaller than 1, 0.0001. Right? If we convert that into scientific notation, we get 10 to the minus 4. So log of 10 to the minus 4 is minus 4. Okay, so essentially we're just looking at the power on 10 after we've converted our number to some power of 10. What about this? Log of 4. Well, 4, can we make that into a power of 10? Well, we can't make it into a power of 10, but we can at least do our best to guess. Log of 4 is between 10 to the 0, which is 1, and 10 to the first power, which is 10. Somewhere in between 10 to the 0 and 10 to the 1. So what does that tell me about the value of the log of 4? Well, it's going to be somewhere between 0 and 1. To be more specific, we're going to need to use a calculator. You might guess that it's 0.4. Unfortunately, it's not that simple. But we definitely would use a calculator, and I'll go over how to do that in a minute. Turns out the answer to this one is actually 0.6. Okay, so let's try this one. If the log of x is 0.4, then what's x? So here we're trying to reverse it. In the previous problems, I was giving you log of some number, and here I'm saying log of x is 0.4. What would x have to be? Well, if you remember our definition of log of 10 to the x is x. If our log function evaluates out to 0.4, then it must be 10 to the 0.4 power, which is 2.51. Again, not expecting you to be able to do that by hand, but easily on a calculator we can raise 10 to that 0.4 power. So that comes to our final definition. If we know that the log of x is some value y, then x is 10 to the y power. Okay. If taking the log of something gives you some value y, then to undo that, we raise y to the 10th or to base 10, and we'll reverse it to get x again. Solving log functions on a graphing calculator is pretty easy. On a TI-89, it is quite hidden. It is diamond 7 that will type log into your calculator for you. Alternatively, you can type catalog L to scroll down to log, or you could just type in log parentheses. Log and natural log are two different things. Natural log is the LN button. Okay, so we're not going to be using that in this class. On a TI-83, it's a lot simpler. There is just a log button right on the left side. Okay, and many other calculators have a log button as well. TI-89 is one of the few that doesn't have it just explicitly shown for you. All right, here is my second attempt at the graph, now charting the log of each object. You can now clearly see everything on the graph. Electron being the smallest, down at -18, remember that means it is 10 to the minus 18 meters in diameter. The thing I like about this graph is that even though the Earth and Sun are quite different in size, the Sun's much, much bigger than the Earth, you can see they're relatively close to each other compared to, say, a virus or an animal cell. Similarly, humans and blue whales, they appear to be relatively close to each other as well, compared to, say, a human versus an animal cell. So these types of graphs are useful for comparing things that are of vastly different scale, and we will use them plenty when we're talking about acids and bases. All right, if you have any questions, please let me know. Have a good one.